Okay. Hey, friends. Woo! I don't know what you're here for. All right. Thank you all so much for coming. Let's get started. Since its public release in 2007, Clojure has been a language by experts for experts. Rich never tried to sell Clojure because he believed there was no point in trying to convince someone who wasn't already inclined or identifying with the problems that Clojure addressed. Intentionally designed to be used by professional developers who are encountering costly programming problems like complexity of state, cognitive load of language features, challenges of information, and coupling in systems. All right, raise your hand if this is part of your Clojure story and how you got in. All right, that tracks, cool, cool. The core team authentically gaining our trust is an important part of the community story. We trust Clojure because it earned our trust. Why? Simplicity, stability. But how? Because Rich wanted Clojure to be a stable tool for professionals and not a platform for experimentation. It is stated explicitly a couple times in the history of Clojure, PDF/presentation. Clojure could not be a lab for experimentation. This is the story of how we've been using Clojure as a platform for experimentation. Oops. Hi, I'm Jordan, AKA Lambda. And in 2019, I was unknowingly our first test subject, trying to convince someone who wasn't already inclined. I'm not sure which definition Rich had in mind here, but I would not, in no way would I have considered myself inclined to Clojure, much less inclined to programming. I've since discovered that there's no such thing as natural talent. Nobody comes out of the womb knowing how to talk to a computer. That is ridiculous. There are certainly people that have built similar mental models before, and if you discount their pre-existing knowledge, these people can appear to have a natural talent. But this is something we call preparatory privilege. I didn't even have that. I was a 28-year-old high school dropout who identified as a creative and went to Grateful Dead University on Facebook. I hadn't touched a computer since coding MySpace at my parents' house on Windows XP. Today, I'm a staff software engineer at one of the largest banks in the world, where I get to focus on helping developers achieve success with my favorite technologies. And for the sake of time, honestly, I can't list all the things I'm involved in, but the new shiny is our recently published Pragmatic Programmer's book that I did with one of the people who first believed that programming was for me. So how did I get here? Well, I had somebody, several people in this room right now who believed that I could be a programmer too. I was handed a book that felt accessible to me because it was written in my language by someone who believed that Clojure is for everyone. I coded along with content produced by people who knew some things about pedagogy. But most of all, I found a community where I felt a sense of belonging. I felt seen, heard, valued, and supported. And just as much as Rich had intentionally designed Clojure for the professional programmer, he had also intentionally established and required a tone of supportiveness, positivity, and respect. And that had been seized upon, maintained, and enforced, thank you, Sean Corfield, by the community itself as one of their core values and points of pride. The Clojure community is friendly and helpful, and we tolerate nothing less. So, yeah, give yourself a round of applause. This community, you all welcomed me with open arms, and it was very intrinsically motivating. So, it was 2022. I had been in the industry a couple of years when Daniel Higginbotham hit me up on Twitter. Remember when we used Twitter? And the concept, a way to help beginners get unstuck. The implementation, a live call-in Zoom show kind of based on improv, where we, presumably the experts, could answer questions, offer clarification, and interact directly with Clojure novices. Initially dubbed the Clowncil, me, had not anticipated that maybe committing to coordinate, host, and produce a Zoom call until the end of time with no end date maybe wasn't the wisest, most sustainable plan. After about 8 months of doing Zoom calls every 2 weeks, we took pause to reevaluate what we were doing and how we were doing it. Around this time, I helped to organize and host the Clojure conference. During a community update, some Canadian fellow named Raf told us how he had gone rogue and started teaching Clojure at a boot camp. He had demoed a couple of the tools he worked on, and I immediately recruited him to our cause.
Hello, I'm Raf. You may you may remember me from a talk I gave a few years ago, solving problems the Clojure way. I look a little different now. COVID does a lot to you. I've been programming for 20 years, most of that blissfully in Clojure, and I also have a deep interest in learning theory, teaching, and mentoring. And so in 2023, when Jordan brought me into the fold, we started experimenting with mentoring a small group of new developers, holding office hours, doing show and tells, various types of activities. And we brought 3 of them last year to last year's conj, and we're happy to report that as of a few months ago, all 3 of them are now full-time software developers. So earlier this year, Clojure Camp sort of rebooted as an online learning community. Now, it's not a boot camp, you'll see why and how, but it's meant as a community for anyone interested in learning and mastering Clojure. And we see ourselves also as a playground for educational experimentation, providing various offerings like office hours and group coding sessions, which we'll talk about more later. But we also care deeply about the human side of things, keeping our learners motivated, fostering an inclusive community like we have in Clojure, and creating a sense of belonging. So far this year, we've had over 200 members join. Now, some are more active than others, like in any online community. But we've had over 300 hours of events, and we're supported by just a handful of mentors so far. But after this, it's going to change. And a big thanks for Clojurians Together for funding our work so far. And as we've been iterating on Clojure Camp, we frequently ask ourselves, how do we teach more effectively? And answering that has involved studying about the theory of learning, the art and science of teaching, and trying to put those things into practice. And today we're going to share some of what we've learned and some of our thinking behind some of the things we're doing at Clojure Camp. Now, teaching is often thought of just as, transmitting knowledge. You know some stuff, you give you a lecture or write a book, and ta-da, learning happens. And today, I'd like to challenge you to see teaching as learning experience design. And here I'm making a purposeful analogy to user experience design. When teams like yourselves make applications, you undertake UX design to understand how a user experiences your software, and so that you can iterate on your software to help your users achieve their goal. And learning is similar, and teaching is similar. A teacher should understand the experience of their students when they are learning, so that the teacher can carefully design a learning experience that makes the student be able to do something they weren't able to do before. So back to our model of teaching, it goes without saying that some knowledge of your domain is necessary, but to truly leverage that knowledge, some understanding of how learning works is crucial. And Jordan is going to be covering that in a few moments. But in addition to this knowledge, it helps to design the learning experience with intent, to deeply think about what does the learner want, consider various approaches, and plan things out. And if we really want to make great experiences, we should think of teaching as a process of learning and experimentation, We deliver our teaching experience, measure our impact, and iterate and iterate and iterate. And at the tail end of this talk, I'll be walking us through a sample design process with Clojure Camp as the example. But first, let's get into some theory.
Woo, I'm back. So, pedagogy. Fancy word, just means leading children. Constructivism. Fancy word, just means we learn by actually doing the thing. Which is probably why I didn't used to think that I was good at math. I would understand what the teacher said when they said it, like, okay, yeah, that tracks. But it probably would have helped if I actually did the homework. So more antiquated forms of education relied on students passively receiving information, listening, reading, watching, substitute teacher day stuff. But now it's generally accepted that teaching is the process of guiding a student's construction of a mostly correct mental model and then creating conditions where they can exercise that and activate it, and if necessary, they can renovate it, they can add to it. But as a student approaches learning a subject, they have some preconceived notions. If they're wrong, I guess they're misconceptions. But it's during the application, during these activities, the student is able to clean, renovate, and update their mental model. So as a student exercises the model, it's reinforced, and then eventually it's internalized as knowledge. But this is done during rest, which is why it's important to take care of yourself, you're a role model, and make sure that your student does too. A tired, stressed, overwhelmed mind has a much, much harder time squash merging the stuff from the new feature branch into the main line. So, with enough deliberate, reflective practice, a novice will become a competent practitioner, and then, eventually, an expert. An expert has built out these really large and densely connected mental models. And they have an extensive mind palace, they know exactly where everything is, they're able to access it quickly, and you would think this is good. But unfortunately, it actually creates a paradox. Because their mind palaces are so much bigger, so much more powerful, and you know what they say, with great power comes great responsibility. But in exchange for these superpowers, experts sacrifice the ability to understand what's developmentally appropriate and what's in scope enough to create lessons within a learner's proximal zone of development. This is often abbreviated as ZPD. We'll hear more on that. But if the teacher disregards the capacity of their learner, then they unintentionally overload their kind of local storage cache before it actually has the ability to rebase onto their mainframe, their persistent data structure. So experts are usually well-intentioned, but often tell on themselves and unintentionally shame their learners, which I don't think we want to do that, right? When they do things like this. So these are the sins of experts. When you organize an explanation based on the deeper principles, first principles, instead of basing it on what the learner already knows and basing it on the mental models they have already constructed. That's why it's important to take consideration where your learner is at. The other thing we do, and we're all guilty of this, I'm guilty of this, actually everything I say I am guilty of at some point. This has been a fun process to go through, learning that. When we start info dumping randomly and without any structure, and they don't have any similar mental models, it's really bad because it can cause a learner to form flawed mental models. And if you've ever tried to teach functional programming to someone's mental model is object-oriented, you may be familiar with how much harder it is to renovate than it is to initially build. The other thing we do is when we pair code, if you're able to solve a problem, you need to be able to explain why as you're doing it. And this is another reason why teaching helps you in the end as well. The other thing that you do is if somebody asks you a question, Never say, oh, we'll just do this. We'll just fire up an Emacs buffer. And because if they're asking, they don't know. And it's very, very demotivating because it indicates that the problem is trivial. And if the problem is trivial and they're asking about it, it indicates that they're stupid. Do we want to call our learners stupid? Yeah, who said yes? Somebody said yes. Yeah. Well, I guess if we go with Socratic, well, you know what? So let's look at what we do have control over. So first of all, be kind. Just conduct yourself with basic human compassion, and you're probably going to be fine. That's how I felt it out. We want to aim for that proximal zone of development. Zone of proximal development, ZPD. So the reason why a lot of tutorials are hello world is because it's very intentional. It is curating very quick wins and pruning and controlling and reducing failure in the beginning so your learner can gain momentum. Every hello world you've ever done was carefully orchestrated so you couldn't fail. You also want to lead with curiosity and be authentic about it. Get to know your learner and know what they want to do, how they want to do it. If you are looking for inspiration on the types of things you can set up, look at Bloom's taxonomy for ways that you can shift your teaching model from that passive, watch, listen, to an active show, tell, discuss. You also want to, arguably, if you take one thing from this slide, as a teacher, your job is to order and curate content. It's something I've been doing for people over the last couple days of going to the conference talk and knowing their previous experience and being like, hey, I think this would be good for you. Same thing with if they get books that may be outdated, Brave and True, it's been a little bit. Just going through and marking off the chapters that are kind of irrelevant or they shouldn't focus on, that's teaching, that's good enough, you should do that. The other thing, we want to give hints freely. There is no cheating when it comes to learning. You're allowing your learner to learn better when you give them hints as scaffolding, and then you're able to take the scaffolding back piece by piece, and you're not just pulling out the rug from under them. Other important takeaways, I know you don't want to, but mirror your learner's environment. I know we all like Emacs, me too, but if you're working with somebody that uses VS Code, use VS Code with Emacs key binding, that's fine. It helps reduce their cognitive load. The other thing is social stuff matters. Like I said, just going back to being a kind human and trying to incentivize learners to learn together. It creates accountability. Raf is going to talk a little bit more about that later. And don't be afraid of live code. One of those valuable things you can do as a teacher is to just be vulnerable and make mistakes. That's valuable. Again, this is how I ended up teaching, is making a lot of mistakes in front of people. So when we initially did this dry run, we did so many dry runs. All of the campers said, okay, yeah, that's great, but you really missed like a big part of this for me, which is the human aspect. And then when I think back to my experiences, I realize the same thing. The Clojure community is friendly and helpful, and we tolerate nothing less. Because our community was targeted and to a certain extent self-filtering, and because Rich thought from this stewardship mindset in authentically winning your trust, as a result, every Clojure user was a fanatic. I like that you got that, yeah. Every Clojure user was a believer. They were passionate, inspired, and just wanted to share that knowledge with others. And that's what drew me to Clojure. So although I may not be able to relate to the specific technical problems that Clojure addresses, I'm able to relate to the people so that we can solve technical problems together. That's good enough for me. So belonging and connection at scale, that's what I see as community. Connection is the energy that exists when we feel seen, heard, and valued, and we're able to give and receive without judgment. And although it would be great to feel guaranteed to be connected at work, we can't really control anything outside of ourselves. But having a place to make mistakes free of judgment is really imperative to learning. We call it psychological safety. And most people are understandably a little hesitant to admit their incompetencies to their superiors, who are supposed to rate them based on performance. We see this as a gap that Clojure Camp is able to fill. Domain cross-pollination and peer-to-peer learning and pairing helps our ecosystem, which in turn helps improve our code quality and our recruitment options. It low-key seems like everyone wants to complain about the lack of Clojure jobs, but I'm not really seeing a lot of people do anything about it. For the sake of our shared interest in keeping things simple, I think it's time for us to invest in ourselves. Clojure Camp is a digital third place, a place with a code of conduct that's independent of a workspace, meant for people to connect authentically over a shared interest. We're based in science, and we experiment with different ways of teaching and learning. We have coined this, some of the things we've been experimenting with, we've coined as incremental mentorship, and Raf is going to elaborate on this later. So, why is having a place like Clojure Camp important? Rich is retired. It's our responsibility to maintain the life force of the community that we love. Learning is hard, and teaching is hard, and why would we make it harder if it doesn't have to be? So, ooh, I missed these amazing, gorgeous slides. So we're about halfway through now, to give you a little, I know that felt like a closing thing. So the next few minutes, Raf is going to share about how we're putting these learning insights into action, and then I'll come back and I'll wrap things up again, and then we get to hear Colin and Alex.
Thank you, Jordan. So let's put some of that theory into practice. I'm going to walk you through a sample learning experience design process and that you could apply to your next talk or book or blog post. And I'll be using Clojure Camp as the example, partly because examples are a good way of teaching, but also because we want you to learn about Clojure Camp and see what we're doing and maybe inspire some of you to join us and help us. So let's start with some analysis. What is Clojure Camp's overall goal? We want to offer a learning experience to support would-be Clojure developers that are currently underserved by existing offerings. What are our delivery constraints? We choose to be remote and with learners from many time zones and speaking many languages, and we have to leverage relatively few volunteer mentors who aren't professional teachers. And who are our learners? Broadly, it's anybody who wants to learn Clojure, but that doesn't tell us much really about who they are and what they know. And so here, once again, we recommend stealing an idea from user experience design, which is personas. And in this case, we call them learner personas. But personas in general are stand-in caricatures of certain groups that you might be trying to target. And in this case, it's our learners. And I recommend answering these 4 questions. Who are they in general? What do they already know about your subject? What do they want to do? Which is different than what do they want to learn, and we'll expand on that in a second. And do they need any special considerations? For Clojure Camp, we've created 2 personas. The first is the career pivot. She was an accountant, kind of getting tired with it, and a friend has recommended, hey, you're kind of good at this Excel stuff. Maybe you'd enjoy a job involving more programming. And I use Clojure, I love Clojure, so do Clojure. And so not knowing anything better, yeah, they start going down that path. But they are currently working full-time and managing family and all that, so they have kind of a limited bandwidth, but they have some time to learn. The other persona is the comp sci grad. They recently graduated. They've been learned how to do basic programming in their studies, and they've fallen in love with it. They've dabbled a little bit with web dev, although none of it was covered in their courses. And they want to become a senior developer, and they see Clojure maybe as an opportunity to learn functional programming and level up. But also, they'd love to have a career in it if they could get a job in Clojure land. But they speak English as a second language, and they're in a different time zone, so we got to be aware of that. Now, I should mention that when people say they want to learn Clojure, they typically actually want to do real things, not just learn. And so it's usually something like, you know, doing data science in Clojure or building web apps in Clojure. But learning is fractal. And learning how to build web apps in Clojure, you have to have an understanding of programming and the basic fundamental concepts that involve programming in all languages. Then all the things that Clojure brings to the table, and then the 1,000 different things you have to learn to do web development because we've dug ourselves a giant rabbit hole. Plus, all the different practices of being a software developer or engineer. That's a lot to learn and a lot to teach, but that's just the modern world of software development. Now, next is the hard part. We leverage all our domain knowledge as teachers. We take all our pedagogical knowledge, and we hold our objectives and constraints in mind. And we make design choices about our learning experience. So let's get into our hammocks. Normally, when you go through this process for a self-contained lesson, like a book or a video, you would identify your learning objectives, what you want your students to be able to do after they've done your lesson. You might think about how might you actually assess those objectives with some sort of test or exercise. And then you would work backwards to prepare your lesson to lead up to that. But Clojure Camp's scope is much broader. We're not doing a single lesson. We're trying to orchestrate a bunch of learners to learn. So it's not like we're designing a 3-hour learning experience, but more like a 3,000-hour learning experience. And since we are teaching adults, we see our primary role as supporting their self-directed learning by helping them navigate the vast expanse of things to learn and resources that are already available, providing some structure to motivate them to learn, and providing a community to help them get through their frustrations of learning something new. Also, the variety of knowledge and goals in our Clojure Camp learners poses a design challenge, because the danger of a one-size-fits-all solution is that it actually ends up being kind of one-size-fits-nobody in particular. And so our approach to this is to, one, offer a diverse set of experiences for students to be able to choose from and help them also navigate which of those things might work for them, and to offer adaptable experiences that are amenable to students from a variety of skill levels. Now, earlier when I said that learning experience design requires domain knowledge and some pedagogical knowledge, I did skip out on one more thing that is worth knowing, and that is knowing what already works in your teaching context. Because other people have been here before, no matter what you're teaching and who you're teaching it to. And luckily, the teaching of programming is actually very, very well studied, because university professors who teach introductory programming are academics, and they treat it like a science. And we can leverage the many, 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 many years and papers on teaching programming to help inspire us and advise us on what to teach, in what order, and in what way. And so picking from that multitude is kind of the crux of the design process, and I'd like to highlight a few ideas that we've been trying at Clojure Camp. And the first of these is what are called learning roadmaps. As self-directed students try to learn a domain, they constantly ask, what should I learn? What should I learn next? And should I learn macros today? And there's or what are monads? I was like, don't worry about it. Not a Clojure thing right now, yeah. So there's a lot of value in helping them navigate that process and providing suggestions on where to start and where to go later. And kind of from a constructivist perspective, that is one of the core roles of a teacher. It's to order content that is appropriate based on the mental models of a given learner. And so in the small, that means within a lesson, figuring out like in what order should I explain things, what things should I even explain. But these kind of entire domain maps are an example of it in the large. So at Clojure Camp, we've been working on a resource we call our topic map, and this is just maybe 5% of it on the screen. And for hundreds of different topics, it helps answer for a student, what do they need to learn first, what should they be aiming towards, and what can they skip? Macros. For macros, knowing what a macro is and being able to use a macro, yes, that's fundamental. But to be able to write a macro, you might be able to go years and years without doing that.
I've never done it.
Now, the map includes concepts and skills, but also practices like debugging and reading reference materials, and norms, like being able to judge whether code is quality or not. And our big dream with this resource is to link every single one of these things with a resource that already exists somewhere that covers it. And you can help with that. Now, software development requires a lot of knowing, but that knowledge is in the service of doing things. And to teach practices in programming, one of the best ways to do that is worked examples. And what is a worked example? It's basically just having a teacher work through a problem step by step, which in our case is basically like live coding or recorded versions of live coding, showing all the steps, including the mistakes and how to handle them. And one of my favorite ways of doing worked examples is coding together in groups, also called mob programming. And every week at Clojure Camp, we host a session where 4 to 10 students work together on a problem, often a day 1 to 5 Advent of Code problem, and they take turns, 3 to 4 minutes each, doing whatever they want, sometimes undoing the previous person's work, and then they pass the torch. Participants get an opportunity to actually code using real tools and a real REPL workflow, and they get to see how it feels without having to set it all up. And participants who are earlier in their journey, they just watch. And when it's their turn, they might ask a question or get some clarification. And they make a ton of mistakes. But that's kind of the point, because when coding alone, when you get stuck with a null pointer error and a 500-line stack trace, students get frustrated. And they just give up and come back maybe a week later. But in a group, someone there is probably going to be able to help, or help maintain the motivation, help maintain the momentum. And currently, we've always had a mentor at these sessions, and hopefully we'll have some of you running them in the future. But we're also going to try to experiment with people who aren't 10 years into their journey, but maybe only 1 or 2 years into their Clojure journey, because we think that these sessions mostly are about facilitation, and we want to experiment to see if that works. Now, having seen a problem being solved, the next step for a student is to have problems to work on of their own. And there's tons of resources like that available, exercism for Clojure, hundreds of problems for them to work on, some of them which might look like something like this. Write a function that will sum up just the even numbers in a list. And even in the moments that since I've displayed this, I imagine many, many of you have already figured this out in your heads. And it might look something like this. Take that list, filter it using the even function, and maybe use apply with addition, maybe reduce, and you've got your answer. But even for experienced programmers who haven't seen functional programming or haven't memorized the entire Clojure standard library, this can be a big ask. It's a pretty big jump from 0 to 1. But maybe we can do better. What if we go give them a little bit of scaffolding, and we tell them, solve this using these 4 functions. Now they don't have to look at the entire standard library. Now they just look at these 4 functions and try to, figure out how might they compose them to answer this problem. But we can go even further. Well, actually, before that, this is currently what we're doing in our exercise library. We're kind of giving these sorts of hints. But we can go further. What if the problem looked something like this? You've got 4 blanks and 4 functions. Just figure out which ones to put where. This still requires knowledge of how the threading macro works, how each of those functions behaves, and what the problem is asking in general. But it is much more approachable. And of course, people can work up to being able to do it from a blank slate, but this gives a stepping stone. And we hope that, we think that now using GPT, and we might be able to take all of the exercises that we have, and maybe all the ones on Clojure, and generate these types of variations, and maybe make it adjustable, so that a student can kind of set their level and get a problem that is appropriate for them. So that's still an open project, and if you're interested in helping with that, come talk to us later. And just in case you're Googling this later, these are called faded problems. They're related to Parsons problems. And there's a lot of different variations that can be done this way. And the last effective thing I want to talk about is peer learning, because often we think of learning as just being between students and experts. But as designers, if we think of ourselves as designers of a learning experience, we don't always have to be the one delivering it. Because two students at a similar level can work together and complete a task that neither of them could do alone. And this works because they each have incomplete models and of a given topic in their mind, but with their powers combined, they can move forward and learn and fix each other's understanding. And even in a situation where one student is slightly ahead of the other, and because that other student, let's say, is already able to complete the task independently, they can still benefit from having to teach their peer, because the act of teaching requires them to exercise their mental model and fully clarify it so that they can explain it clearly and help their peer. That's one of the best ways to learn, is just to teach. And the other great thing about peer-to-peer learning is that it scales. We don't need as many mentors to actually pull it off. And so at Clojure Camp, we built a tool, which we call our peer-to-peer pairing tool, where every week students get an email being like, hey, are you going to participate next week? They put in their schedule, and then they get matched up for one-on-one sessions with peers and with mentors. During a session, they might work on a problem together, or it might be, maybe they'll discuss a topic, or they'll just work on things side by side because they wanted to set aside this time to work on Clojure, and maybe just ask each other questions once or twice during that hour. And so far, we've coordinated several hundred sessions that way, and going forward, we plan to give them a little bit more structure and advice on how to best make use of those sessions and explore better tools for pairing. So I've introduced a few things that we've implemented. There's a bunch of things that we're doing that I'm not going to cover today. But in general, we like to think about things, these different offerings, as are they active? Do they promote active learning? Are students actually doing stuff or just watching and reading? Because active is usually better. Are they adaptable? Are they suitable to participants of different levels? And how scalable are they? And what kind of support do they provide? And finally, speaking of experimentation, a proper experiment should be tested. And currently, Clojure Camp only does this in a qualitative way. We look at which events attract more students, which ones get them coming back, and which ones do we get good feedback from. And we brought 6 campers to the conference. They're wearing our buttons. Many of you have talked to them already, but in the last few hours, I encourage you to reach out and get a first-hand report on how their learning experience has been and what they're trying to do. And going forward, we want to get better at this. We want to get better at the evaluation experimentation. And we have some ideas in mind around just analytics, tracking participation over time. It's a challenge because everybody's in a different place, learning slightly different things. We're also thinking about like a badge system that might be either self-administered, peer-to-peer administered, or mentor-administered, something we'll be working on over the next year. And if all goes well, we'll report back next year on our progress.
Oh, happy Halloween soon. I got the Halloween text on here. So, thanks, Raf, for providing that context of Clojure Camp. So now we're going to wrap it up. Returning to the history of Clojure paper. These quotes really resonated with me, and I thought they would be good to end on. With a couple of edits. That one was Raf. This is good. So when I embarked on Clojure, I was not, nor did I ever intend to be, a language experience designer and steward. And from now on, I'm responsible for Clojure Camp. The success of Clojure Camp has changed my life and my career in ways that I would have never thought possible. Ultimately, the success of a language rides upon the success of its users. Whatever design or evangelism we do, users telling their stories, a process we can't control, that's what causes a language to spread. So although Clojure was never intended to be a place for experimentation, Clojure Camp is. So this is Clojure story. That's also Clojure Camp's story. I want to ask you, what's your story? Today I learned, take nothing out of it, take this. From our experiments and our studied, we've gathered a few things. Start with curiosity and compassion and aim to create a safe, supportive learning environment, psychological safety that has hands-on, active learning in quick wins that are designed to build confidence and momentum and reduce failure at first. Be generous with your help and hints. Learning actually doesn't have to suck. Have fun. So teaching. Teaching is walking with learners. Walk with them to simplify and curate content thoughtfully. The teacher's goal should be to walk alongside the student and prescribe level-appropriate resources, ultimately that guides the construction of mental models and then building on it. And then creating conditions where the student can actively test this model to reinforce it. Here's a little hint. Rebels are so good at that. So your last thing, encourage belonging and connection at scale. That's what I call community. Be authentic, be vulnerable, and don't underestimate peer learning and mutual support. So what have we learned? Everyone has something to learn, and everyone has something to teach. We're very conflicted about the learner-mentor model. We're trying to play with what to do because we've realized this. A lot of what we've talked about here today was inspired by, this is, when Raf and I got together, he was like, yo, there's this book. And I was like, oh yeah, this looks whatever. And then later on, I forget why, but I actually read it. I was like, and I hit him up like a month later, yo, this book. And he was like, now you've read it. And I hadn't read it, so we started a book club. And that was like a year ago. And we encourage you all to do the same thing. So within the next couple weeks, organized in the Clojure Camp Discord, we will be doing a way to actively exercise what we're talking about here today. And I hope that maybe another book club springs out of experienced engineers that want to learn how to teach better. We had to cut so much for this. So as Raf mentioned, we have some outstanding work to be done around Parsons problems, worked examples, faded examples. We have some hypotheses to test. I know personally, I had been taking some time away from interfacing with students to, I know this is the third hammock reference, but to get in the hammock and truly comprehend what this is, because I had no background in this. And I have to remind myself that that's okay. But I invite you all to join me as I get back into the arena, because anyone who has experienced the fulfillment of helping somebody change their life will tell you that it's work, but it's worth it. Here are some keywords to Google if you want to just understand more about this stuff. Here's a shameless plug that I mentioned would happen earlier. If you are a beginner, intermediate, even advanced, Clojurist, check out this book, Prog. We just published it. Alex Miller, who will be speaking shortly, no relation. It has 30 teasers that are literally designed to test your existing mental models and find flaws that Alex has realized are flaws from maintaining the Clojure Slack forever. All right, these are some key resources that we, if you want to know that all those quotes came from History Clojure, really good book and talk. Teaching Tech Together, Greg Wilson was actually one of Raf's professors, fun fact. And a lot of the warm belonging stuff comes from Brene Brown. So that was the work, this is the worth it. Personally, I want to thank all of the people that believed in me, again, believed that programming was for me. And the initial campers and mentors, most of all, thank you because we've learned and we've grown so much together, and I am so grateful for like the meaningful work that I have now, and I really hope that you're able to pass this meaningful work on in ways that are meaningful to you. And that's been really, really fulfilling. So thank you for that. Okay, yeah, that's.
And thank you for listening.